So the second concept that we are going to deal with is experimentations. But before going through the theories that have been done on this domain, we should first admit that experiments play a fundamental role in the empirical sciences, both in acquiring new knowledge and in testing it. And modern science has its roots in the very idea of experiment, as divided by Galileo Galilei during the so-called scientific revolution in the 17th century. One of the main achievements of this revolution has been to recognize that pure observations are not enough for the comprehension of the natural world, and that to probably interrogate nature interference with the natural world itself by means of experiments is necessary. An experimental procedure aims thus at controlling some of the characteristics of a phenomena under investigations with the purpose of testing the behavior of the same phenomenon under some controlled circumstances. Accordingly, an experiment can be defined as a controlled experience, namely as a set of observations and actions performed in a controlled context to support the given hypothesis. Well, a trend has recently emerged toward making experimental scientific method take center stage in the informatics as well, given that informatics possesses an empirical component, even without considering here the debate about the prevalence of the empirical versus of theoretical one. It is natural to ask about the role of relevance of experimentations in it. Thus, experimentations and experimental scientist methods has recently been under attention in computer science and engineering, both at the general level and in scientific disciplines. See, for example, the case of empirical software engineering. Experiments are recognized as relevant in this field as they help build a reliable base of knowledge, lead to useful and unexpected insights, and accelerate progress. As you can see in the screen, we said that experimentation is well understood in the philosophy of science. And this is the ideology of William Stanley Jevons, who said in his classics on the principles of science in the 19th century that observation and experiments are the primary source of experience, and that's knowledge in his view. To explain that, he proceeded to explain how experiments are intended to give insight in the causal effects of different and ideally independent parameters on a phenomenon or system. When they are varied in a controlled setting, they reveal unknown properties, confirm or refute hypotheses, help in debugging theories or prototypes, and set on the stage for alternate explanations or designs. One only can guess why experimentation has developed so inventively in the various sub-eras of informatics or computer science. There is no shortage of experimental methods in the field. Some were developed to great sophistications like visualization, case studies, simulation, and parameter tuning. Sometimes statistical methods are employed, as an example in the analysis of optimization methods. In eras like information system, there is a lot of experience with experimentations. Example on the interplay between human behavior and design as well. An often confirmed experience is that a good experimentation is hard. And then here comes the role of the second theory, which is posed by Milner, who made the case that theory and experiment can well go together. For example, in a classical field like algorithm design, we're going to show you guys a picture of an algorithm design example. He said that it has long been common practice to assess algorithms by their asymptotic properties only. However, their actual behavior in practice is now increasingly being studied as well, even though that the models of the latter are typically still theoretical, with informatics becoming ever more interactive, large-scale, and distributed. Experimentation is increasingly called for in all eras to understand the unknown behaviors of a design or system in any realistic setting. The essential role of experimentation in informatics was explicated before, notably by Denning and later by Tichy, when he wrote, "To understand the nature of information processes, computer scientists must observe phenomena, formulate explanations and theories, and test them." Interestingly, in those eras where experimentations did not come naturally, the approach to science through experimentation has led to a kind of rediscovery of the experimental methodology. It has occasionally led to separate fields like experimental algorithms and empirical software engineering, experimentation, which isn't a simple way to get experimentation integrated in a field. In other cases, the experimental methodology is explicitly brought under attention as a possible way to publishable result, provided suitable standards are followed, as done by the EEE journal Pervasive Computing. To sum up this point, experimentations in informatics require sound and variable experimentation protocols. In this case of multidisciplinary research, these protocols should follow standard practices that are recognizable across discipline boundaries. Now, let's pass to answering one of the most important questions of this work, which is how to write a perfect experimental report. In order to answer these questions, we need to follow some steps. As you can see, the experimental report consists of 13 parts connected between each other in order to make a nice and a clean experimental report. Basically, these components are in order. The first one is the title. The purpose of the title is to sum up your work in a single phrase or sentence. It needs to be clear, specific, and brief. Its meaning should be obvious to most readers. So I'm going to explain these 3 adjectives that should be in a title. To be clear means technical terms and abbreviations should be only used if they will be familiar to your readers of your report. Specific means to give enough information to enable the reader to know if the research is likely to be of interest of their own field. Finally, to be brief means to avoid obvious phrases like the role of, studies of, an examination of, an investigation into, research into, an experiment into. Titles with these words are often too long or not descriptive enough. Now, the second component is the abstract. Abstract's aim is to summarize the entire report for quick reading. It should include your reasons for doing the work, your methods, your findings, and your conclusions. It needs to be both interesting and easy to read. Also, the abstract should be independent of the rest of the report. It is a mini report which needs to make sense completely on its own. The references should not be included. Nothing should appear in abstract that is not in the rest of your report. Concerning now the words as it's written, the abstract should be in one paragraph of 100 into 200 words. And finally, you should write in the past tense in a single paragraph. It is recommended that you write your abstract after your report, so you have a general idea about what to put. Now moving to the